Hello, guys and girls. Welcome to another episode with Cloud with Raj. Today, we are going to cover a topic which is very hot right now, platform engineering. Today, we're going to learn what the heck is this platform engineering, how is it different than DevOps, how you can learn it, do you need to learn Kubernetes to do platform engineering, and many more questions. As always, I don't like to hear from pen and paper instructors. I like to hear from folks who have done it. I'm very excited to be joined by two esteemed guests today who have implemented platform engineering as well as wrote blogs, gave talks on it. So without further ado, let me introduce today's guests, Christina Andonoff and Carlos Santana. Christina, can you please introduce yourself?
Yes, thank you, Raj. I'm Christina Antonov. I am a senior specialist solutions architect at AWS, and currently I specialize in helping organizations build internal developer platforms, mainly on EKS, but we'll talk about that later. It's a pleasure to be here.
Thank you for coming. Carlos, can you please introduce yourself?
Yes, thank you, Raj. I made it to Raj YouTube channel. Hey,
Woo!
woo! I'm a senior specialist solutions architect for AWS, mainly working with containers at modernization, helping our customers. I'm also a CNCF Ambassador, and working with Christina on this project on internal developer platforms.
Excellent, excellent. So first question, Carlos, to you, because you are very passionate about platform engineering. What is this platform engineering?
So platform engineering involves building and maintaining a set of tools, services, and infrastructure that empowers the software developer teams to deliver their applications more efficiently. It involves around creating an internal developer platform. And we'll be talking about that. What is an internal developer platform? But the platform engineering, it allows the developer to focus on their code and application logic rather than getting confused or waiting for that infrastructure that is needed for the application that they require to put it in production. But at the nutshell, that's what platform engineering, but we'll be talking more about it in terms of internal developer platforms.
How is this internal developer platform different than DevOps?
I don't think it's different at all. I think that both concepts are working very well together. DevOps is close collaboration of development and operations, and the platform is just that. It facilitates that collaboration, and it provides an ability for a broad spectrum of developers to work how they want. We have, on one hand, we had developers that they just want to write code. They don't want to understand every single detail of running a high availability database. They just want their code to run. And we do have other teams, so it kind of brings them together. And then on the other hand, we have other types of developers who are geeks. They want to understand the ins and outs. They want to be able to also contribute to that platform. And when we build the platform and we democratize it, we can serve all kinds of developers and collaborate with them. So DevOps and platform engineering, they're closely coupled together, in my opinion.
Carlos, any input on that?
Yeah, DevOps. I think DevOps is not dead, by the way. That's the first thing.
That's good for people like me. Yes.
So what?
That's good for people like me who did a lot of DevOps and new to platform.
No, we're still in DevOps today. Christina said it, like the collaboration between operations, doing operations, right, and doing development, writing your code, your business logic, and also like putting in production. That's operations. Platform engineering is a subset or specialization. Like we have DevOps, which is the big one, and then we have like platform engineering that takes care of building these portals. Actually, sometimes there's portals for the developers that they can request some infrastructure and some pipelines and GitHub repos, handling some guardrails and standards, right? That's a subset. Another subset could be within DevOps, we can say like the people monitoring the application, SRE, like observability, logs, metrics, those type of things. Another person is like communicating with security, like how we need to secure our applications, who's validating them, who's auditing. So I think all of those aspects in different roles, in different verticals of the specialization, the DevOps is a big umbrella, right? The big umbrella that everybody is working to get that software efficiently and fast, right? Like the Accelerate book was about measuring like the velocity from the time that the request for a new feature came in, right? And we open a ticket, and we'll be talking about GitOps, tracking it to get into production, that software, making a CD or DVD, right? How fast can we do it? Well, in back in the times, what taking months, like to deliver a feature on a CD, right? Before we had cloud, it took months. Then we had cloud, and still it takes, so some organizations that are big, it takes them 3 months, a quarter. So how can we reduce that for our business, not even for the developers, right? For a business to deliver that software as fast as possible. And if it's a small feature, it should take a day. If it's a bug patch, it should take an hour, right? And how do we have automation in that? And that's part of DevOps. I just described DevOps.
You said one thing is like sometimes the DevOps processes work through ticketing. So the developer team will submit a ticket and the central team will work on it. And each team may have different infrastructure as code. Seems like platform engineering is about abstracting some of this burden and enables developer team to self-serve what they need. So Christina, does that mean that the ticketing is dead? What if some organization still want to track everything through tickets? Is it possible with platform engineering?
Yeah, let's go in detail on that. That's a very near and dear topic to my heart. So when you go and deploy microservices to compute, usually you have a pipeline, and that pipeline is automated. And then when you need other resources, usually on the infrastructure side, because your application needs more than just compute to run, it needs database, you need dashboards and other things to make it run. You have to go through most companies, not everywhere, but you do have to go through ticketing system where the developer would open the ticket, the platform engineer would pick up the tickets. It takes some time there. It's sometimes there's a lot of back and forth. Just the process is very manual. There's that breaking of the process, so to speak. It's not automated. And that slows development down. And it's just not effective, and it's not good for either side there. So the idea here is to not remove the tickets completely, but to automate that process. And we can still have the ticketing system for reporting, for compliance purposes. We can automate the ticketing system even. Like we can say, okay, after you deploy my application and my database, go and update this ticket. And so I have track and at compliance time, if there is that track record needed, it can be pulled up.
Okay, another thing that you two talked about is the abstraction. One of the responsibility of the platform team is to abstract as much details as possible, so the developer team just submit some claim or some Git merge, and then the platform or infrastructure gets provisioned. Can you shed some light on the role of abstractions in platform engineering?
Yes, as I mentioned earlier, developers don't want the cognitive load of knowing every single toggle of the infrastructure, but they do need to control over some of those toggles. I need to be able to have smart defaults if I'm a developer. I want to have, let's say, a cheap database to develop on. But then when I go to production, I want a high availability database. And I don't want this to be, to have to set those explicitly. It can be the defaults for me. But then if I decide that I want to change something, I want to change the memory or how much CPU I need, I want to be able to still do that. To have control over it, not to go through a ticketing system. So I think there is like when platform works with developers, if they were to early on in the process just come together and then start iterating on what that interface, that perfect interface looks like. And it doesn't have to be perfect from the beginning, but just as the end user is involved, just start iterating and making progress. You can create a great balance of abstraction there.
Gotcha. Okay. So this actually brings me to my previous work experience. I was a developer, and then I was also part of the Cloud Center of Excellence. So I always struggled with standardization versus autonomy. When I was a developer, I wanted to do a lot, and the platform team will constantly say, no, Raj, no, you cannot do that. And when I was platform team, I'm like, how much should I restrict folks to do? How much should I standardize versus how much autonomy I give them? So Carlos, how does an organization determine this balance, this delicate dance?
So yeah, and it comes with the making the decisions of not hiding too much, right? When you hide too much, then you create an abstraction that then people, then it creates an illusion, right, of something that is not what it is. We were talking about databases. For developers, we want to give them the ability to provide that they need a database. Yes, that is MySQL. Yes, but the operations team is the one that is going to be able or in better position because they do it. That's their job. They do it a lot, deciding like what are the properties and the characteristics of that database when it's in dev, when it's in staging, when it's in pre-prod, when it's in prod. And that'll be a cognitive load if the developer needs to decide that for the one app, the second app, the third app, the fourth app, right? So that way the platform engineering with the DevOps, like it's part of the DevOps, right, creates an interface or creates an abstraction saying, give me what information do I need for this application to be successful? You don't have to give me all the details. Like what is the backup window? Like the developer doesn't know. What is the retention place? Well, it depends on the environment. So in terms of abstractions, and we also need to be able of creating abstractions. I've seen some engagements that they don't create abstraction. They just create a translator. They gave like all the possible values to the developer. So now they can like put whatever values they want in there, but that's not helping because they're still need to make the decision, the cognitive load. So can we have a balance? Like you were asking about the balance, like the balance comes from DevOps, like the collaboration of talking versus like requesting and consuming, and then who's my role? Like coming together to the same table and asking like, we need to make this software successful. And this software needs a database. This software needs a VPC. This software needs IP addresses. This software needs worker nodes, right? In case of Kubernetes, right? We have autoscalers. Like how are we going to autoscale the nodes? So that's where platform engineering comes in. Like talking together to come into an agreement, like what is going to be the standard and what is going to be the abstraction for the development team to be able to onboard a new project very fast and then get into production.
So let's switch gear a little bit to practical implementation. So Carlos, could you provide some insights into practices and tools from AWS that organizations can leverage to build a platform?
Certainly. One of the popular tools that people are using is Amazon Elastic Kubernetes Service, EKS for short. It's a managed Kubernetes that has a programming model, actually. It has a programming model where you can create your own custom resources of types that you can create abstractions so that you can create a platform on top of a platform. You can say Kubernetes is kind of a platform. So you're building with that platform another platform. So providing that interface. Lambda and Lambda is also another one that people can use to do automation. I've seen a lot of customers using Lambdas to do CI/CD, for example, right? That's another avenue of like so fulfilling that abstraction. But in terms of internal developer platforms, we have also open source, or you can build on your own. We have our code X, right? We have code pipelines, we have code build. We have our new code catalyst, which is a dev environment that you get. I was actually using it today, connected to VS Code, and I was able to deploy something to compute, like Fargate, a Node.js Fargate. In a few minutes, I was able to get it. So those are the tools, but those are like building blocks, really good building blocks, managed services that then you can compose a internal developer platform, or a developer platform. Those are like the building blocks in AWS, and then we can talk about open source.
Yeah. I would like to hear a little bit more about the open source part as well. What are some of the tools, Christina, that they can use to build the UI as well as some other open source components if you want to highlight?
Oh, yeah, of course. So let me start with Carlos mentioned something here where is like you can build internal development platform many ways. And we have seen enterprises build those in-house custom made, and so on. So now that all these open source tools emerge, there is a way to actually stitch them all together and use what's coming out of the community and put it together. And then another thing that comes out of that is when you build your own, you have to then support it, update it, bring up new features. Whereas if you adopt open source tooling, those features come from the community most times. And then it's going to get you possibly 80% there. And the other 20 you can pad. You can still build your own tooling, but you can first, like if you find bug or some functionality missing that thing the community will benefit from, you can go contribute it. And then, still you can build some custom logic. For example, like updating those Jira tickets. If you still need them, that would be custom. So some open source projects that have helped build internal developer platforms are, one of them that is gaining popularity is Crossplane. It is it's a CNCF incubating project, and it's gaining popularity because it democratizes the options of what you can do with Kubernetes. Like you install it on top of the Kubernetes, it extends the API, and then you can deploy pretty much anything with Kubernetes. And in the front of it, you ask for the developer UI. We can put another open source project and just link it together, like Backstage, for example, which is another open source project that can that you can customize and use that to view in a single pane of glass what your platform looks like.
Gotcha. So I want to double click on this cross-plane part because I think that's the important point. Seems like one major advantage of creating an internal developer platform is you no longer need to learn and maintain different infrastructure as code. For example, maybe team A uses Terraform to provision Lambda. Team B uses CloudFormation to provision RDS. Team C maybe uses Pulumi to provision some other resources. Now, you are saying if this internal developer platform adopts a Kubernetes controller such as SCK or Crossplane, they no longer need to learn and maintain these different infrastructure as code between different teams. Is that a correct assumption?
Yes, that is a correct assumption. It all becomes consistent. And here there is an important point I want to make, because usually how it used to work in the past, when you have those separate infrastructure as code tooling, your code would live in one repo with your pipeline that deploys it, but then your database, your S3 buckets, everything else would live in a completely separate repo, and they will get disjoint. And that disjoining, now if you build a platform, you can merge them together, you can join them and have one repo that is not your service. It's like your whole component, the service and its dependencies. You can manage it from one site. And that also helps with updating and, most importantly, deleting resources, believe it or not, because oftentimes when you delete a service, you forget the database. It gets left behind, and you keep incurring cost for that database. So now you do get that unified one place where you can control everything.
Also, talking about advantages, so this is one of the good advantage. Another term or feature which is gaining a lot of popularity is GitOps. So where does GitOps fall in this platform engineering, Christina?
GitOps, now when we start building internal developer platforms on Kubernetes, with Kubernetes controllers, one thing that Kubernetes controllers do is continuously reconcile those resources. So before, when you use, let's say, Terraform or any other tool, it's more push-based, meaning every so often you would push and you'll make changes to the infrastructure. Well, chances are, if you used it, you probably have seen that diff, like nothing changed, yet something changed in the past 3 months. Nobody touched it, but something happens. So that something is usually someone that got paid in the middle of the night, maybe, or some other, let's say you have a Lambda function that went and checked your bucket and put it back in compliance. You might have some process that sits outside of it that run, and now that Git that you have, that state in Git is different than what is actually out there, because nothing is continuously reconciling it. So now when you put DevOps practices in here, that continuous reconciliation loop makes sure what is in Git is what actually is deployed. It ensures that it enforces all these practices, because if you remove the reconciliation, that state can deviate.
Gotcha. And I know we are all wearing Kubernetes t-shirts, right? So is internal developer platform can only be created on top of Kubernetes, Carlos, or can they be done without using Kubernetes?
No, Kubernetes, the benefit is that you get that reconciliation loop, right? That GitOps aspect of running. An internal developer can be done with a different platform or a different place, right? Kubernetes is becoming in that way, if you're using Kubernetes, it's like using Kubernetes as Jenkins. If you remember, I did a lot of Jenkins in my past. I bet a lot of people doing this. Yeah. It's just a runner of jobs, right? So in Christina was explaining, it's like running those jobs to deploy the infrastructure the same way it's deploy pods or containers, and make sure that you have 3, and one gets deleted, then it creates a new one. So it's doing that for AWS. If you're not using Kubernetes, you still can do an internal developer platform. Backstage is a, like Christina mentioned, is a CNCF project, and it has plugins that you can build a catalog. So Backstage is more of a catalog of like choosing what you want to build, and it has a server behind it, which can be your Jenkins runner kind of thing, like your logic. Also, you can attach to Backstage AWS, another CI/CD pipeline. So it could be AWS code build code pipeline. So AWS release a plugin that you can put in Backstage that you can say, I want to deploy a Lambda or Fargate, and then Backstage itself will run a CI/CD pipeline and will get you your infrastructure. You will have that risk of going dev, like if somebody changes that, then somebody needs to trigger that reconciliation, right? And that you miss that, but it still can be built.
Okay, but seems like you mentioned controller and operator. Chances are any organization who adopted Kubernetes already know about this controller operator. They know the RBAC model, the GitOps model. So one advantage of building IDP on top of Kubernetes is they can reuse all this knowledge.
And skills, right? If you are looking for a job and you know Kubernetes, these companies have a lot of Kubernetes, right, to manage, and a lot of Kubernetes to write, and they already have those skills. They don't have to have different like organization that use this tool versus that tool. If they're running their applications with Kubernetes, then they have folks that are aware of that, and they're hiring.
That brings me to my last question, right? So we talked a lot about, like you talked about hiring, and also we talked a lot about different technology like Crossplane, GitOps. GitOps can have different tools, Kubernetes. So what is the best way for people to learn about this building platform so that they can advance their career?
Yeah, so if you were to learn how to build an internal developer platform on Kubernetes, I highly recommend you know Kubernetes inside out before you start bringing in an IDP into it. So if you have first your very solid foundational layer of knowing Kubernetes and a whole other things to make it production ready Kubernetes, like you have to know how to manage add-ons, core DNS, how to monitor it, most importantly, metrics and so on. So once you have your bases squared, then you can start exploring and opening your horizons of what is Crossplane? How do I run it? We have, me and Carlos, we manage the Crossplane OrnicS repo. It's a very good way to get started. It has plenty of examples. So with Crossplane, it's a great way to get started. Go learn Backstage, see how you can hook it up. Also, ACK, see what the difference between ACK and Crossplane are. and when to use one and the other, and so on. You can keep going from there. Then you can go to how to mix it up with other tools that come from the community, such as Argo and Flux for pipeline, and deploy with those pipelines. And that will definitely get you started. Carlos, do you have any other thoughts on that?
Yeah, Kubernetes ecosystem is very large. If you're not, if you want to get into Kubernetes, right, you can get into it as a developer that knows like how to create a Helm chart or deploy a Helm chart. Sorry, I meant deploying it. Creating a Helm chart will be an admin, but those two roles are usually the ones that organizations are looking for, right? Developers that know how to write the code, and also like they're familiar with the basics, right? And then the CNCF offers certifications, and then with those certifications, there's educational courses that you can take from CNCF or other third parties to learn Kubernetes, kind of the basics. If you want to have a structured way of doing it, there's also like many online courses like Udemy and YouTube. But I usually recommend, if you're serious of getting into it, try to get the CKID. That's the Kubernetes developer certification. The other aspect is, if you are maybe in a position or looking or have a background on operations, maybe you did a lot of Jenkins, maybe you did a lot of virtual machines, right? Or you're right now doing a lot of things with EC2, and you want to get into the operations aspect of like, our team is going to use Kubernetes, then I'll recommend the CKA. There's a certification for Kubernetes administrator, and that will go into more in the in and outs of like, what is a worker node? How do I upgrade Kubernetes? How do I configure it? How do I do the different secrets, config maps, like more of the configuration and the admin of running Kubernetes, which, by the way, is also helpful when you're running with EKS in terms of knowing that. But you don't have to worry about the control plane. That's handled by AWS. So those two aspects. If you're more in the security, then the next one will be the certification Kubernetes security. I think that's the glance of like your journey, but always hands-on, right? Get the tutorials, go to the different projects they have getting started, and then there's a lot of training also from AWS on this open source technology that we have managed services.
Cool. And one thing I will say is, go to the free events and conferences. You learn a lot by talking with like-minded professionals. I definitely learn a lot from chatting with folks like Carlos and Christina. So a lot of CNCF events are free. There are CNCF meetups, and definitely platform is super popular right now. So any CNCF meetups, chances are they will be talking about platform. All right, with that, I want to thank Christina and Carlos. But before I end the show, so Christina, how can people connect with you in social? What is the best way? Twitter, LinkedIn, etc.
The best way is LinkedIn. I do have Twitter. I don't use it much. So find me on LinkedIn. Find me on the Crossplane Slack. I'm there.
Excellent. How about you, Carlos?
For me, find me in the comments. I'm usually in the comments on YouTube from Raj channel. I'm a very popular channel. But other than that, on Twitter, this is my handle, Santana PR, and also LinkedIn. So I have, those two places. And other than that, if you are a maintainer of open source or a contributor to open source, you will find me in the different Slack channels like Kubernetes Slack and CNCF Slack.
Excellent. Well, I thank you both for coming into the show. Let me know, viewers, if you found this episode helpful. If you have questions for Christina and Carlos, put it in the comment sections, and I will see you guys and girls in the next episode. Bye.
Bye.
Bye.